right, so this is the first question from the second test. All right. And something I've been doing here in working through these, gang, is this is going to shock you, but I've been making some mistakes. Okay. So if you see me make a mistake, yell at me. Like, I know what I'm doing here, but I might put a wrong number or forget to multiply something. But something I've done a couple times is, and this is important for you guys, is I've used the wrong function and to plug in. So, like, the mistake I made wasn't difficult, but, like, so for instance, if they give you a graph of f prime and they ask, like, what's f of 3, I just took the f prime of 3 value off the graph and used that instead. So just, my main point is, be super careful about what function you're using and what function they're asking about. Read it really, really carefully. Because that's just a super easy way to lose points, even when you know what you're doing. It's kind of like a careless mistake, and they've gotten me a couple times on these questions here. So, but you guys are, more attentive than I am, I imagine. Anyway, they're giving me a graph of f of x, so there's that thing, and they're giving me the areas in here, which means we're going to be able to integrate, right? We can find the change in the antiderivative of f. And they tell me all this good junk. H of x is defined by some other stuff, so it's a piecewise function, and g happens to have f in it. So I definitely expect the AP folks to do something like this year and give you like just a hodgepodge of functions all mixed together and ask you all kinds of junk, okay? So the first question says, show H is continuous. Continuity has 3 pieces to it. You should know these, or you should have a little cheat sheet next to you when you're taking this exam, but I would have this memorized. You want the limit from the right of, H of x. So that says the right-hand side is headed somewhere. That's exactly the same thing as the left-hand side is headed, and that's exactly the same thing as h of -1. So you got to show those 3 things are equal. All right. So the left-hand and right-hand limits are going to be easy because we have this definition of h up here. So I'm going to write it up here. We have the limit as x approaches -1 from below of h of x is just the limit as x approaches -1 from below of the left-hand function there, which is this. And if you have any questions at all, just let me know. And again, if I make a mistake, yell at me. All right. But you're just going to plug -1 in, right? That's all you got to do. This isn't a hard limit. The limits you're going to see are like these piecewise functions, but it also could be L'Hopital's rule, which we've talked about a couple times. And they popped up on these other questions too. By the way, when you plug in -1, what do you get? You get 1 minus 3 minus 2. That's a -4. Okay. The right-hand limit as we approach -1 is the limit as we approach -1 of g of x, which is the integral from 2 to -1, or of x, I guess, right? Okay, but because they gave us these areas up here, the integral from 2 to -1, check this out. So here's 2, and here's -1. The area in there is 4. So something I want to highlight is we actually want this integral to go from 2 to negative. So this is the limit. I'm just plugging it in is all we're going to do, right? So we get this. But anytime you have to integrate from a greater number, 2, to a lesser number, -1, especially when you're just using areas from a graph, if you're unsure about it, just flip those limits and it changes the sign of the integral, okay? So you can flip the -1 and the 2 and it just changes the sign of it. And the area between -2 and 1 is +4. All right, so the answer to our integral is actually -4. And that's seen too, when you integrate backwards, it just changes the sign of the area. So if it's positive, it becomes negative. Okay, but what we just showed is the right-hand limit and the left-hand limit, well, this is the right-hand limit and this is the left-hand limit, but are the same value. What that proves is that the limit exists. So if the question says, show the limit exists, that's it. All right, now we got to show that h of -1 is also that, but h of -1, since the equal bar is right here, is just g of -1, which we just basically found is -4. Okay, so you're going to write a little sentence saying, since, and this is probably a little wordier than it has to be, but since the left-hand limit equals the right-hand limit, equals g of -1. It looks amazing. I love it. That ninja is super lucky. And these all equal -4. My son just brilliantly built a Ninjago motorcycle. We'll see if it breaks before this class is over. Okay. Hey, Lucas, shut that door, man. Okay. We've been doing slow motion videos over here. I don't know if you guys ever watched Lego Masters. I don't know, but it's a show where you have to build things. And one of the episodes, they broke everything in slow motion at the end. So my kids have been building stuff and dropping it, and I've been recording in slow motion. So that's been fun. All right. Anyway, that's how you show something is continuous. Hang on one second. Yo, Luke, shut the door, dude. Ah, what just happened? Give me you back. No. Ah, okay. All right. Now we need to order. Hello, bud. Order these from smallest to largest. What they really mean to say there is from least to greatest. You probably don't care. But smallest to largest means like their size. Like if you wrote h double prime of -2 and h double prime of 2, well, this is larger, right? It's bigger. They mean least to greatest here, okay? Anyway, I don't even know what h is anymore. Where are we? So -2 is going to be using this definition up here. So h double prime, so h prime of x equals one of two things. It either equals 2x plus 3, or it equals g prime of x. Okay? And that happens when x is less than -1 here, and when x is greater than -1 here, but less than or equal to 11. Now, I don't know about at -1 if it's differentiable. We'd have to check. So remember, just because it's continuous doesn't mean it's differentiable at -1. But they want the second derivative. So we're going to derive these bad mamma jammas again. And that's going to give us 2 when x is less than -1. And it's going to give me g double prime of x when x is between -1 and 11. Boom. All right. So I'm just going to go down into part C here with this, but we'll do part C somewhere else. So we want h double prime of -2. That has to be 2, because that's less than -1. H double prime of 2 is actually g double prime of 2, which we got to find. So let's go back up here to g of x. We got it's like a wild goose chase. G prime of x is just f of x, and that's something we talked about a whole lot. Okay, g prime of x is just f of x because when you derive an integral, let's go over that rule real quick for anybody who's with me. When you derive an integral that goes from a function, doesn't matter what these are, of some other function. I'm just making this up. What's your favorite function? E to the x? Great. E to the t squared dt. Okay. So if this was our function, and we had to derive it, remember, that's an f. You plug in the top limit. All right. So because a derivative and integral are going to cancel out. So we're going to get the same function, but it's with the top limit plugged in. And that is just x, right? Root x squared is absolute value of x, but we'll just say x for right now, times the derivative of what you plugged in, minus e to the x squared times the derivative of what you plugged in, 2x. Okay, so that's how you derive an integral function, a function that has an integral in it. All right, so anyway, when we derive g of x, we just get f of x times 1 minus f of 2 times 0, so just f of x. But that means that g double prime of x is f prime of x. So following along here, we need h double prime of 2, which is g double prime of 2, which is just f prime at 2. And here's f. We need f prime at 2. Why do we know what that is? Oh, we don't know what it is. Okay, we just know that it's negative, right? It's the slope at 2. I don't know what it is. I can just tell that it's less than 0. Right? There's no way for me to find that right now because they didn't tell me what f was. I know that seems weird. The reason why we don't need it, by the way, and the reason why I knew that just by looking at that for a second, is because they want us to put them least to greatest. And when they ask you that question, a lot of times what happens is one of them is positive, one of them is negative, and one of them is 0. Okay? So my bet, h double prime of negative 2 was positive 2, right? H double prime of 2 was negative, just something. I'm betting that h double prime of 10, which is going to be g double prime of 10, which is going to be f prime of 10, I'm hoping that equals 0. And holy crap, look at that. See, it's flat right there. That's a minimum value. So f prime is 0 there. So to put them in from least to greatest, the least of them is the negative, right? So it's f prime of 2 is less than f of 10, which is 0, which is less than, oh, not f, we want h, right? H double prime of 2, yes, is less than, I've confused myself, h double prime of 10, which is 0, which is less than h double prime of negative 2, which is 2. So that's the order they want there. All right. So I'm gonna steal C and just take it somewhere else. Here we go. Come on down here with my sound effects. Ah. Boom. Okay. So here we have some limit. Turns out, first thing you're gonna do is like plug in 0, right? So when you plug in 0 here, you get g of 6 plus 3e to the 0. That's on top, which is, and I'm just going to write this really sloppy for right now. That's just g of 6 plus 3. Now, that means we got to find g of 6, which is a pain in the butt. But g is this function here, which means g of 6. So this is what I'm saying. Like I think this is a little more convoluted than the AP test is going to be. This has me running all over the place to find all these different values. The AP test might make you do that a little bit. I don't think they're going to make you run around as much as this does to go find all these different values from things. It's just a lot going on here. That's all. So, but I mean, individually, you should be able to do all these pieces. I just think it's a lot all in one question. But either way, g of 6 is the integral from 2 to 6 of f of x dx. And the only reason why I happen to know that thing is because the area from 2 to 6 on f is 3, but it's negative. So g of 6 happens to be negative 3. And wouldn't you know it, if g of 6 is negative 3, this is 0. Okay, so that's the first thing I'm checking. And you can also check that the denominator is going to be 0. So what that means is we're going to get 0 over 0, which you should expect when you see a limit anyway, which means we can do L'Hopital's rule. But we got to write this a little bit neater. So the first thing I did was just investigate to make sure I got 0 over 0. Now I'm going to clean this up so I can write it. So we're going to say we can use L'Hopital's rule because, or since, the limit as x goes to 6 of g of x, I'm just going to write out what the top is here of that, is equal to g of 6 plus 3, right? That's what the limit is, and that happens to be negative 3 plus 3, which is 0. So the numerator's limit is 0, and the limit as x goes to 6 of x squared minus 36 is 0. I can use L'Hopital's rule. Yes. So what that means is this limit becomes, remember what it says? It says you can derive the numerator and the denominator and just evaluate the limit again, and the answer is the same. So if I derive that numerator, I'm going to get g prime of x plus the derivative of an exponential thing. So we're deriving the numerator again right here. Boom. Is the derivative of that exponential is e to the 12 minus 2x times the derivative of the exponent, which is negative 2. And that is all over 2x. That's what L'Hopital's rule tells us. And now I'm hoping to just plug 6 in there. So I got to find g prime of 6. Let's go back up here. G prime of x is just f of x. So g prime of 6 is just f of 6. And luckily for us, this is a graph of f of x, and f of 6 is 0. So g prime of 6 is 0. That's what we just showed there. So this equals 0 plus 3 times. If you put 6 into there, you get 12 minus 12, so you get 0. So e to the 0 is 1 times negative 2 all over 2 times 6 is 12, and that's negative 6 over 12, and that's negative 1/2. Okay, so that's that. What question was that? That was C. What do you got to do? E? Oh, come on, Brian, pass water. All right, D is evaluate this integral. So here's something you should know. The integral of h prime of x dx from a to b is just h of x from a to b. Y'all know that. We've done that 100,000 times. That's hyperbole right there. I think that's hyperbole. Is that hyperbole? That's an exaggeration at least, right?
It's not hyperbole.
Thank you. So that's example hyperbole. A non-hyperbole would be that Mr. Smith is the greatest teacher that's ever walked the face of the earth. That's, that's just a fact. Anyway.
Of course.
The integral of h prime from a to b is just h of x, okay? So that is correct. And you see that's what they're getting at here, right? They're hiding that h prime in here. We need to separate this out so I can just get to that h prime. And you'll notice they've plugged in some function for y. Why would they do this to us? They've plugged in some function into that h prime of x. What that means is we're going to have to do a u substitution. Don't let them trick you for that, okay? The integral of h prime of x is h of x. The integral of h prime of 2x minus 4 needs a u substitution because there's an inside function. But first we're going to do this. 3 integral from 1 to 7 of h prime of 2x minus 4 dx plus the integral from 1 to 7 of 5 dx. I'm separating out. That plus allows me to do that. Okay? I'm going to jump right down here, forget part E for a second. I cannot integrate h prime of 2x. That does not just become h of 2x minus 4. It'd be great if it did, but it doesn't. I need to do a u sub. So u has to be the inside function, which means du is a 2 du. But I don't have a 2, so we got to put a 2, not du, 2 dx, right? So we got to put a 2 on that dx, which means we got to divide by 2 out front, and that integral becomes, nice and easy, 3/2 h prime of u du. Okay? One thing to remember is that the limits change. 1 to 7 are the x values, which means, using this definition, if x is 1, u is 2 times 1 minus 4, which is negative 2. And if x is 7, u is 2 times 7 minus 4, which is 10. So our integral is going to go from negative 2 to 10. All right? And that's plus, the integral of 5 is just 5x from 1 to 7. So this becomes, now the 3/2 is only on this first integral. This becomes 3/2 h of u from negative 2 to 10. Plus, this becomes 35 minus 5. Plug in the 7 minus plug in the 1. That's how you handle an integral, right? So then this becomes 3/2 h of 10 minus h of negative 2 plus 30, which is, now we have to go back and find these stinking values. So h of x is right here. H of negative 2 is on this interval. We might have already found this. When you plug in negative 2, you get 4 minus 6 minus 2. That's h of negative 2, right? Negative 2 squared is 4. Negative 6 minus 2. So that happens to be, what's that, negative 8? No. What? Negative 4. Yes, negative 4. There we go. So h of negative 2 is negative 4. I know I'm all over the place here. I hope this is making some sense. This is 3/2. Oh, I got to find h of 10 too. Okay, well, whatever h of 10 is, minus negative 4, and then plus that 30 at the end. Cool. So the only thing I'm missing is what's h of 10. That's going to go right here. All right, so because we're just evaluating over here. So let's go back up and see what h is. H is this dumb function here. So h of 10 is just g of 10. But g of 10 is the integral from 2, right? Starts at 2. Where is it? Oh yeah, 2 to 10 of f of x dx. And the integral from 2 to 10 is just the areas in here. So from 2 to 6 is a negative 3. And from 6 to 10 is a positive 2. So this equals negative 3 plus 2, which is negative 1. So h of 10 is just -1, bam, bam. And if we felt like it, we could simplify this. I really don't think you should. Honestly, on the AP test, leave your answer like this. Save yourself the time. Don't simplify it. Okay? And I'm not going to simplify it either because I might mess it up. Who knows? All right. So there's only one part left. Let's do part E. You okay? What's happening?
Excuse me, Mr. Smith.
What up?
Hi, it's me, Jihoon. How you doing?
I'm great. How are you? It's me. Who?
I'm good. Do you remember me?
Who is this?
Jihoon.
Oh, Jihoon. Oh, you're Ji-Young.
Jihoon from like, I don't know, 4 years ago.
Yeah, I remember you, man. I remember you.
So I'm not understanding the question. I'm good. Can you just give me the answers for the next exam?
Yeah, no problem. You're gonna find me on Venmo.
All right, thanks.
Later on.
All right.
Okay. Now we gotta do part E. Thanks, Jihoon and Ji-Young. K of x is this solution here. Find the fixed solution y equals k of x in terms of x and blah, 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 blah. Really? Oh, but it's for x is less than -1. Okay, I got it. Where's our definition of this thing? Okay, so let's come over here. So, don't let differential equations scare you. They're not going to be super crazy difficult when they give them to you, but you got to know how to handle them. So, when they give you a differential equation, it's just going to be a dy dx equals some junk. If they ask you to solve it, they'll say, find k of x, or find a particular solution. That means you're going to have to integrate, but you have to separate the x's and the y's. All right? Now, this is weird because I have this dumb h prime of x sitting here, and you're like, well, what the crap is that? But because it's for x less than -1 specifically, and because they've defined h of x as this function over here, h prime of x, when x is less than -1, is just a 2x plus 3. Okay, that's just the derivative of this piece. So all they're doing there is making it seem more complicated by writing h prime of x, but all that really is a 2x plus 3. So if you see a weird function, you're like, how am I supposed to know what that is? Take a deep breath, look and see what they give you, and try to figure it out. Great advice, super helpful, yeah. Just do it. But dy dx is going to, I forgot already while I'm just rambling to myself. 2x plus 3, okay. So this is probably one of the more important parts of this entire exam here, okay? I really think you're going to see a question like this where you have to solve a differential equation. Like, it makes very, very big sense that they're going to ask you to do this. All right, get out of here. Oh, that's on the picture, whatever. So what you're going to do is you need to separate by multiplication and division, all right? So we're going to divide by y minus 1. That's that. And we're going to move the dx over to here. Okay? What that sets us up for is the integral and the integral of both sides. Both integrals are relatively simple, right? This just becomes, you can do a u sub here, but this is just going to become ln of the absolute value of y minus 1. That's going to equal x squared plus 3x plus c. Remember, you only put the plus c on the x side. And we're basically done. That's the calculus portion of that question. We need to solve for y, and we need to find what c is. Okay? So the first thing we're going to do to get y by itself, you got an ln in there. Anytime you got to get rid of an ln, you're going to e both of those as exponents, okay? Because e to the ln of the absolute value of y minus 1 is just y minus 1. But over here, this is going to be x squared plus 3x plus c. All right, and now I got to show you something you're not going to like. It's not, again, not difficult, it just looks a little weird. So check this out. This is how you're going to handle specifically exponential equations that pop up from differential equations. So we had a differential equation, we solved it, and we got an e to a power here. All right, when your plus c is in your exponent like that, follow along with me here. So you guys know this rule, right? If I said, hey, what's e squared times e to the 4th, you'd all be like, yo, that's e to the 6th, because you add the exponents. Okay, another way to write that is this. E to the 2 plus 4, that's e to the 6th, can be broken apart like that. E squared times e to the 4th. What that means is we and you don't have to do this, but this is how answer keys usually look for this, can break apart that C. All right? That's exactly the same exact thing. I hope you see this. This right here is the same as this right here. The benefit, sort of the right-hand version of this is that because C is just some number, I don't know what it is, e to the C is also just some number. So what they'll usually do is rather than call it e to the C this makes total sense, they'll call it A. They'll say, hey, that number's just A. And then I'll move it out front instead of leaving it at the back of this whole thing. So they're going to say that this is just equal to AE to the x squared plus 3x. So when you see that happen on an answer key or on the day of the AP test, all they're doing is taking the plus C and rewriting it so it's times e to the C. And they're saying that's just a number. Let's call it A. You can call whatever you want. You know, if your name were, I don't know, what's a cool name? Victor, you could call it V. And then you put a V here.
Come on, man. You could have just said Victoria.
No, I thought about it and I was like, I can't use someone's name. Okay.
All right, I see.
Plus, your name's Tori. All right. Anyway, well, usually they call it A, okay? Okay. So we still got to solve for y. The absolute value could be a little tricky, but here's what the absolute value does. This is a little bit weird. Absolute value either does nothing or it changes the sign of what's inside of it. Absolute value is a very lazy thing. For instance, the absolute value of 4, that's just 4. It didn't do anything, right? So the absolute value of x could just be x, right? If x is positive. But if the absolute value of negative 4 is negative 4, technically, right, which is positive 4, then the absolute value of x could also be negative x, right? It can't be both. It's one or the other. Depends on what x is. So the absolute value of y minus 1 is either y minus 1 or it's negative, the opposite of y minus 1. It depends on if y minus 1 is positive or negative. And you might be saying, how the crap am I supposed to know if it's positive or negative? Well, let's just look what they gave us up here. They said, hey, by the way, the point this thing goes through is negative 2, 2. Okay, that's a point on my solution curve. Well, that means, let's keep these here, y will be positive 2 when x is negative 2, right? Well, you plug negative 2 in for x, you're going to get 4 minus 6. Is that okay? But because 2 minus 1 is positive, the absolute value is not doing anything. Again, very lazy function, which means we can just take it away. Okay? Had we got something that was negative over here, like if it was like negative 2 for y, well, now it's negative 3, but that's going to make it positive 3. So we take it away and we make it opposite of what it is. Now, I think like 75% of the time I've seen these questions, they always make it positive, so the absolute value just kind of goes away. So if you're really, really confused, best bet, that's fine, but you might lose a point missing a negative there. But either way, this becomes a 1 equals AE to the negative 2. And right now, all we're doing is solving for our constant. Like we're solving for the plus C, but remember that came that A. So when they say find the particular solution, they mean use the point you're given and find out what the plus C is. So that's what we're doing. So we need to find out what A is. A times e to the negative 2 is 1. So if I multiply both sides by e squared, which is the same thing as dividing by e to the negative 2, by the way, these become a 1, so you're just left with an A, is e squared. So using that knowledge, we have y minus 1. Again, the absolute values go away because it's just a positive thing, is equal to e squared. We also could have just left the plus c there, by the way, and then we would have got c was 2, which maybe you like that better. All right, that's the same exact thing. It would have worked the same exact way, but just most of the time you see them separated out. We get e to the x squared plus 3x. All I did was plug in what a was, and they want us to solve for y. So to do that, we have to add 1. So either your answer is this, or If you left the c up in the exponent, you would have got this. Both of those are totally fine answers. The reason why I separated it out is because like 9 times out of 10, what happens to A is it becomes like A ends up being like a whole number, not like an E squared. It ends up being like 6. And then C would be ln of 6, which is kind of an ugly number to leave up there. So, but either way, that's that. All right. That was the last part, right? Yeah, it was. So